Assalamu alaikum. My name is Sayyida Abida Zara, roll number 21TE111. Today I will discuss about Lab 1, basic plotting of signals using MATLAB. Lab objectives. The objectives of this lab is to explain digital data and importance of digital data in context of sort, search, store and transmit, how to plot signals, writing scripts in MATLAB, creating and calling functions. Task 1. In the context of digital signal processing, elucidate the essence and intricacies encapsulated within the term digital. Digital in DSP signifies an information signal represented as a discrete sequence of numbers, enabling precise manipulation, analysis, and storage, unlike the continuous wave of analog signals. Task 2. Explain how does the choice between linear search and binary search in DSP applications illustrates the relationship between digital data and sorting, and what are the implications for data processing efficiency. So linear search works on all digital data, either it is sorted or unsorted, but is slow for large data sets. Binary search requires sorted data, offering logarithmic search speed but sacrificing flexibility. The implications for data processing efficiency are trade-off between data organization, processing efficiency for digital manipulation. Moving towards task 3, in the domain of digital data, what strategies and techniques can be employed to enhance data transmission efficiency? Some key strategies are error detection and correction, data compression, data quantization, data sampling, modulation techniques, and channel coding. Task 4. Plotting sinusoids in MATLAB. The code generates and plots a sine wave signal with a frequency of 1 Hz over the time interval 0 to 1 seconds with a sampling rate of 100 Hz. We observe effect of changing the frequency alters the sine wave frequency. Effect of changing the time alters the signal's duration and the relationship between time and frequency, so both are inversely proportional. Here is the output. Task 5. Adding title, labels and axis bound to the signal graph. The code generates and plots a 1 Hz sine wave, customizes the plot with axis labels and a title, and sets the axis limits to minus 0.5 to 1.5 for the time and minus 1.5 to 1.5 for the amplitude. By changing the axis function parameters alters the time and amplitude range, and by changing the title and labels altering new visual representation. Here is output. Task 6. Plotting multiple signals in same figure. The code generates two sine wave signals with frequencies 10 Hz and 520 Hz, plots them on the same figure, and customizes the plot with a title, axis label, and limits. So here is the output. Now task 7. Plotting multiple signals in one figure without connecting dots. The code plots two sine wave signals with frequencies 10 Hz and 520 Hz using dots, plays the second signal as sound, and customizes the plot with a title, axis labels, and limits. The output is showing here. Task 7 with another scenario. The code generates a random uniform data vector, plots it, calculates and plots the mean as a horizontal line, and provides a title indicating the operation performed. Here is the output. The horizontal line is showing. Task 8. The function takes a vector x as input, returns its maximum and minimum elements as max element and min element respectively, as shows in the output. Task 9. The function named mymin finds and returns the minimum element in a vector x using a simple loop and conditional statements. The minimum element is showing in the output. Task 10. The function named myMax finds and returns the maximum element in a vector x using a simple loop and conditional statements. Now the maximum element is showing in the output. Task 11. The function named myAverage calculates and returns the average mean of a vector x by summing its elements and dividing by the length of the vector. In the output, the sum and average both are showing. Task 12. The function named mySort takes a vector x as input and returns its elements in ascending order using the sort function. Here is the output. Task 13. The function named myReverse reverses the order of elements in a vector x and returns the result. Here is the output. Task 14. The code creates a subplot with two plots. The first subplot displays a random vector x and the second subplot shows a sine wave y with a frequency of 10 Hz sampled over time t. Here is the output. Now task 15. The function named win4 creates a figure with a 2 into 2 grid of subplots, providing 4 empty subplots for further plotting or visualization. Like in the output, it is showing.